Let's start again. So what I was talking about, say you have a x-axis, you have y-axis, and we have 4 points A, B, C, D. So the curve is a rectangle right now. So A to B will be the first curve C1. This will be C2. This will be C3. And this is C4. So if I want to find the line integral over this total curve C, f bar dot dr bar, this will actually be equal to the line integral over the first curve C1 f bar dot dr bar plus line integral over the second curve f bar dot dr bar plus line integral over C3 f bar dot dr bar plus line integral over C4. So if some curve is the combination of more than one curves, then what I can do here is okay, I can divide it into 3 to 4 small curves and take the line integrals over each of them. So if I want to find line integral over C, what I have to do is I have to find 4 different integrals. But by Green's theorem, what will this be actually equal to? Double integral over A, partial derivative of V with respect to x minus u with respect to y. So in this type of examples where line integral becomes difficult to find out, what I can do is I can switch to the double integral and give the answer. So that's all about the things we have already seen. So now what I want to do is I'll start with the example which we did, and we were verifying the Green's theorem in that example. So the example was, look, as your multiple integral is not done, what I will do is I will start wherever I'm using multiple integral, I will start from the scratch, and I will explain each and every detail whatever is required in that example, in which manner you will be able to do the double integrals too, if you know 12th standard integral or diploma integration very well. So verify Green's theorem for the field f bar is equal to x square I bar plus xy j bar over the region capital R enclosed by y equal to x square and the line y equal to x. So in the previous lecture, we have done the line integral of this. So we graph this function. We know that y equal to x square is a parabola. So this is the graph of the equation y equal to x square. And the line y equal to x. Y equal to x is a line passing through the origin. Since there is no constant term, if this is the line y equal to x. Okay, so y equal to x is the line. So area bounded by this is this area. Okay, A. What is the curve? Curve is this. Always remember that we need to take the orientation anti-clockwise. So this is the origin. This is the point A where these two curves are intersecting. And from A, it is again coming to this point. So our C will be comprising of C1 and C2, right? This thing we have done. I mean, what answer we got? Line integral over C f bar dot dr bar is equal to integral over C1 f bar dot dr bar plus integral over C2 f bar dot dr bar. If anyone who is writing, what was the answer that we have got here? What was the answer? No one. So the answer that we got was, anyway, I will write it down. That was 1 by 15. Minus 1 by 15, sorry. Now, we need to talk about the double integral. So when I'm talking about double integral, I need to first of all study the area which is bounded. So area kahan se bounded hai? From this point, origin, which is 0, comma 0, and this point A. I need to find out what is A, because that will give me the limit for x-axis. I mean, x-axis पे तुम्हें कहाँ तक limit देनी है? That is going to be the information we get from A. So how do we find out A? What is the property of A? A is the intersection of this line y equal to x and y equal to x square. So what I will do here is, at the bottom, I'll do the calculations to find out A. Understand this? So wherever we will have to find out the intersection of two curves or the points of intersection, this is the technique you have to use. And the technique is put one equation in the other. Put y equal to x in y equal to x square. Q, क्योंकि at point A these two curves are intersecting, तो A point दोनों में आएगा. So that's why we solve this. So we'll have x equal to x square, which means that x square minus x is equal to 0. Take x common, x minus 1 equal to 0. So this gives me x equal to 0 or x equal to 1. Which equation we used? We put y equal to x. So for x equal to 0, we have y equal to 0. For x equal to 1, we have y equal to 1.
1.
So there are 2 points. 0, 0 I have already written. So the A point has to be 1, comma 1. Clear? So in every double integral, we will have to do this. We will have to find the points of intersection. Then, now what I have to do is, I have to cover this area. ये area जो है A, I'll shade this region. This region I have to cover. And this region I have to cover by a vertical strip. What we do is, we take a vertical strip. Okay, vertical strip. Consider a vertical strip. So horizontal movement कितनी है अपने एरिया में ये vertical strip के? This vertical strip will move from Give me the limits for x on which this strip can move.
0 to 1.
यस. सो जो वर्टिकल स्ट्रिप है वो मैं हॉरिजॉन्टली कहाँ से कहाँ तक मूव कर सकता हूँ? फ्रॉम द पॉइंट 0. तो ये पॉइंट कहाँ तक है? 1 तक. सो x विल बी रनिंग फ्रॉम 0 टू x इक्वल टू 1. उसके बाद क्या करना है? नाउ लुक एट लोअर लिमिट ऑफ योर स्ट्रिप. स्ट्रिप कहाँ से स्टार्ट हो रही है? ये कर्व से. ये कर्व से स्टार्ट हो रही है ना. लोअर एंड देखना है. लोअर एंड कहाँ पे है? ये कर्व के ऊपर है. ये कर्व का इक्वेशन क्या है?
Y is equal to x square.
y इज इक्वल टू एक्स स्क्वायर. और ये स्ट्रिप जारी कहाँ तक है? ये लाइन तक. लाइन पे y की वैल्यू क्या है? x है.
X.
Am I right? Please understand this. If you have any problem, you can freely ask, because I know this is the first time you are doing this. तो कोई भी डबल इंटीग्रल है तो पहले एक काम करो कि तुम पॉइंट ऑफ इंटरसेक्शन निकालो, फिर एक वर्टिकल स्ट्रिप ले लो. वर्टिकल स्ट्रिप हॉरिजॉन्टली कितना मूव कर सकती है? दैट इज गोइंग टू गिव यू द लिमिट्स फॉर एक्स. और दूसरा वेरिएबल क्या है? y की लिमिट कैसे फाइंड करनी है? लोअर लिमिट देखो तुम्हारी स्ट्रिप की कौन से इक्वेशन पे है, वो इक्वेशन से y की वैल्यू फाइंड कर लो. अपर लिमिट देखो कहाँ पे है? लाइन के ऊपर है, तो वो लाइन के इक्वेशन से y की वैल्यू फाइंड करो. डन अप टू दिस. नाउ वी जस्ट हैव टू पुट द वैल्यूज. तो बाय ग्रीन्स थ्योरम और सिंपली डबल इंटीग्रल. पहले x की वैल्यू पुट करो. x इज रनिंग फ्रॉम 0 to 1. What is the value of y? Y is running from x square to y equal to x. Partial derivative of v with respect to x minus partial derivative of u with respect to y dx dy. What was v in that case? v मतलब जो j के साथ में है. So that is x is running from 0 to 1. Y is running from x square to x. What is the derivative of v with respect to x? xy का derivative with respect to x will become y minus derivative of u with respect to y. u मतलब I के साथ जो है. Derivative of x square with respect to y is 0. हाँ, अब ये चीज इंपॉर्टेंट है. जो भी लिमिट है वो पहले लेना है. ये किसकी लिमिट है? dy. एंड देन बाद में आ जाएगा dx. If you are writing it, draw the diagram, because I am going to rub the diagram now as its purpose is done.
Yes, sir. Done.
No. Now this is equal to integration. X is running from 0 to 1. Y is running from x square to x. Y dy बाद में dx. Now next thing you have to remember, as I said in the previous lecture, अब ये integration with respect to क्या है? y है. So 0 to 1. What is the integration of x dx? x dx क्या होता है? Anyone? Integration of x? This is the integration of x.
X square by
x square by 2. तो इंटीग्रेशन ऑफ y क्या होगा? y square by 2. y square by 2. लिमिट्स क्या है? x square to x dx. Now put the limits. When we put the upper limit, we will have x square by 2 minus when we put the lower limit, we will have x raised to 4 upon 2 dx, right? Now do the integration here. This is equal to 1 by 2 common in bracket x square का integration x cube by 3 minus x raised to 4 का integration x raised to 5 upon 5 limits from 0 to 1. So this is 1 by 2 in bracket when we put the upper limit 1 by 3 minus 1 by 5. So 5 minus 3 is 2 upon 15 bracket के बाहर 1 by 2. So the answer is 1 by 15. So that day we may have got plus 1 by 5, not minus 1 by 5. So it's not at all difficult. Double integration, whatever we will have in our syllabus, those are not at all difficult. Those are very easy and can be done by this much knowledge and proper substitution. Fine.
Yes, sir.
Next example. Verify Green's theorem for f bar is equal to x times I bar plus y times j bar over the first quadrant of circle of the circle x square plus y square is equal to 1. X I bar plus y square j bar. Sorry, there is a change here. Y square j bar. हाँ, तो Green's theorem verify करना है. मतलब what I have to check? I have to check line integral over the curve f bar dot dr bar. Is this thing equal to double integral over the area bounded by this curve in bracket partial derivative of v with respect to x minus partial derivative of u with respect to y dx dy. तो ये चेक करना है ये इक्वल है या नहीं है. दिस इज द ग्रीन्स थ्योरम. So first of all, let's draw the diagram, as diagram plays a major role here. So what is the curve over the first quadrant of the circle? X square plus y square equal to 1 circle होता है first quadrant, which means that this is the first quadrant. तो इसमें जितना सर्कल का पार्ट आता है that is our area, I mean bounded by this is your area और कर्व होगा ये C. This is your C. From this point to this point, this is your area. What is F bar? F bar is X I bar plus Y square J bar. dr bar is dx I bar plus dy J bar. Now integral over the curve F bar dot dr bar is equal to integral over C x times dx plus y square dy. What will be the substitution for line integral here? Anyone? What will be the substitution?
X equal to y.
No. अरे what is your curve? You can't you recognize the curve? Curve क्या है तुम्हारा? What is the curve? Yash, what is the curve? Shantanu,
X square plus y square is equal to 1.
क्या है ये? Geometrical object कौन सा है ये? X square plus y square equal to 1 क्या होता है? शौनक, what is x square plus y square equal to 1? अरे ग्राफ क्या निकलता है इसका? अगर तुम ग्राफ निकालोगे इसका तो वो क्या बनता है? That is my question.
Quarter.
What you said, Dhruv?
Quarter.
Quarter circle.
It is a latex circle. Circle ना? मतलब I don't know what is latex circle.
Sir, quarter.
Quarter circle, okay. Quarter circle. So now it is a circle in short, okay, a part of a circle. So what was the substitution I gave you when we had circle?
X equals to a cos t.
वहाँ पे a होता है radius. What is the radius here? Right hand side of x square plus y square is 1 square ना? So a is 1. So we will put x is equal to cos theta. What was the substitution for y?
Sin theta.
Sin theta.
Sin theta. So dx will become minus derivative of cos theta is minus sin theta d theta. What will be dy? Derivative of sin theta is cos theta d theta. Fine. Now we have x, we have y, we have dx, we have dy. What are the limits for theta? Theta क्या होता है? Angle. What is the angle here? X axis
0
पे
to pi by 2.
0 to pi by 2. On x-axis, theta is always 0. Y तक pi by 2 हो जाता है. So theta is running from 0 to theta equal to pi by 2. Put all of this in this integration. So this will be equal to 0 to pi by 2. What is x? X is cos theta. Dx is minus sin theta d theta plus y square. This will be sin square. Dy is cos of theta d theta. Let's solve this. 0 to pi by 2. Minus cos theta sin theta. So what I will do is I will take cos theta sin theta common here. Cos theta sin theta, and in bracket, what do we get is, okay, instead of doing that, let's just solve it separately. It's better option. So this is minus sign outside, or make it plus cos theta into minus sin theta d theta plus 0 to pi by 2 sin square theta cos theta d theta. What's the answer for the integration here? If you put cos theta as say t u, so in the first integral, if you put cos theta is equal to u, minus sin theta d theta will become du, right? So this is nothing but u. This will become du. So integration of u du, that will be u square by 2, which means that cos square theta by 2 integration 0 to pi by 2 plus, now I will put sin theta as u in this. Cos theta d theta will become du. So u square du. What is the integration of u square du? U cube by 3, which means that this will become sine raised to 3 theta. Limits from 0 to pi by 2. What is the answer here now? Cos pi by 2, it is 0. And cos 0 is 1. So we will have minus 1 by 2 here. And in the second one, sine pi by 2 is 1 and sine 0 is 0. So that will be plus 1 by 3. Please check the calculations. So minus 3 plus 2 minus 1 by 6. Oh, if you haven't understood the integration, take 2 minutes. Take a rough page, you put the values and you find out the integration properly. So I'll write this properly over here, as I will be starting for the double integral of this now. So integral over C f bar dot dr bar is equal to minus 1 by 6. Now we have to go for the double integral. Done? Now, so double integral over A partial derivative of v with respect to x minus partial derivative of u with respect to y dx dy. This is equal to double integral over the region A. What is v? V is nothing but y square. Just a minute. I think so. I've made this half integral. I mean, we need to take this also. So what we have done is we have took the line integral over the region from this boundary. Just this isn't a closed curve, right? So when I come from this point to this point, look at the diagram. So when I come from this point to this point, this is the first curve C1. But to make this closed curve, I will also have to take this C2 and C3. C2 and C3. What is C2? C2 is the line from this point to the origin. Okay. So let me just complete that. So this will be integral over C1, integral over C2, f bar dot dr bar. This is equal to integral over C2. What is f bar dot dr bar here? X dx plus y square dy. What is C2? C2 is a straight line which is joining this point. Which what is the point? 0, comma 1. I hope you are clear how it is 0, comma 1. So it is a circle with radius 1. So origin से ये point का distance होना चाहिए. And this point is 0, 0. What is our substitution for a straight line? X is equal to x1, which is 0, plus x2 minus x1, 0 minus 0, t. So this is x is equal to 0. So dx will also become 0. Y is equal to, what is our y1? 1
1.
plus 0 minus 1 t. So y is equal to 1 minus t. Dy will become minus dt. What are the limits for t here? T is running from 0 to t is equal to 1. Let's substitute that here. Integration 0 to 1. X and dx both are 0. So first term will go away. Y square 1 minus t square dy is minus dt. We can integrate this. The integral 0 to 1, 1 minus 2t plus t square dt minus sign outside. So integration 0 to 1. Okay, we'll do the integration. Minus sign outside. In bracket, integration of 1 is t minus integration of 2t is t square plus t cube by t. Integration 0 to 1. Now the last one. What is the answer? Can you do that? So that will be t square minus t minus t cube by 3, 0 to 1. So that is 1 minus 1 minus 1 by 3. So the answer is
Minus 1 by 3.
minus 1 by 3. Exactly. So this is C2. So I'll write down comma integration C2 f bar dot dr bar is equal to minus 1 by 3. Now what is C3? So I'll make the change here, C3, and I'll change all the substitutions. What is C3? Can anyone speak out?
Line.
It is a line, but uh,
X equal to 1
uh, just a
and
minute.
Y 0.
Let me make all the changes here. So C3 is the line joining the point 0, 0 and the point 1, comma 0, right? So the substitution we need to make here is integral over C3. So x is equal to x1. What is x1 here? 0 plus x2 is 1 minus 0 t. So dx will become dt here, and x is equal to t. Y is equal to y1, which is 0, plus
0.
y2 minus y1, 0.
0.
So dy will become dt. Oh, sorry, dy will also become 0.
0.
T is running from 0 to 1. Look, if you have MCQ exam, this line integral for a straight line will, I mean, this is the obvious question because it is the easiest one here to find out. So integral 0 to 1, then put the values. What is x? X is t, so this will become t times dt plus y is 0, so here 0. What is the integration? T square by 2 limits from 0 to 1. And so this is 1 by 2.
1 by 2.
Fine. So the line integral over C is equal to, so line integral over C f bar dot dr bar is equal to line integral over C1 f bar dot dr bar plus line integral over C2 f bar dot dr bar plus line integral over C3 f bar dot dr bar. What is the first one? Minus 1 by 6. Second one is minus 1 by 3. And over C3 is plus 1 by 2. So the answer is 0.
Yes, sir.
So once we are done with all this, now let's go to the third one. What we have to do is, as we have found out the line integral, to verify the Green's theorem, we need to find out the double integral. So line integral over C f bar dot dr bar. This we have found and it is 0. Double integral over A f bar dot dr bar is equal to double integral over whatever area. What is partial derivative of v with respect to x minus partial derivative of u with respect to y dx dy. So what is v with respect to x? V is nothing but coefficient of j. Y square. Y square का derivative with respect to x. Anyone?
0.
0. Minus partial derivative of u with respect to y. What is the u? U is coefficient of I, which is x. So derivative of x with respect to y will become
0.
0 dx dy. So integration of 0 is 0. Hence Green's theorem is verified. Green's theorem verified. If you have any doubt, you can ask, or else we'll stop here. In the next lecture, we'll talk about the surface integral now. You can see that the efficiency of this Green's theorem here. To find line integral, we had to find 3 integrals, whereas we got the answer by double integral in just 2 steps. Fine. No doubts. It means this. So we'll stop here. Thank you, everyone.